this is Aaron, and this is Organic Chemistry Lab 2. So in the video, we wanted to explain how we got our last question, which was C2H4Cl2. So I started with the degree of unsaturation. Let's see, there it is. Carbon times 2 is 4, plus 2 is 6, minus an additional 6 is 0, divided by 2 is 0. Molecular weight is 96 grams. Now, if we look at the distinctive peaks, let me go down to it. So 1500 or over, you can go ahead and look on over here. So we have a distinctive peak at 2900. Then I flipped over to our list here. Now, when I was looking at the IR for around 2900, there's a few things. So obviously you have your C with a single bond to an H, and that's within that range. I didn't really see, it doesn't do any carbonyls. We didn't have anything at the 1700 range. So carbonyls were out. We didn't have any oxygens in here, so that also excluded any type of alcohols in there. So then that kind of narrowed it down a little bit. And then the next question was the NMR data. So you had one signal with 2 carbons. So that tells me that there was some symmetry. So that's basically how I figured it out. So if we have, let's see, C2H4Cl2, if there's symmetry, so if you draw your 2 carbons and our line of symmetry, basically both sides have to have the thing. So we're missing 4 hydrogens. So if we put our 4 hydrogens in, again, they have to be symmetrical, and then add our 2 chlorines on each side. So again, if we were to fold it here, these 2 lines are symmetrical. That's why on the NMR you got 1 peak or 1 signal. And then basically our 2 carbons are both an octet. We have 2 chlorines, 4 hydrogens, and 2 carbons, which meets our original formula. So that's how I figured out that last problem.